Basic mathematical operations with vectors can be a bit tricky. So, without getting into too much details, let's see a couple of examples. I have already prepared two vectors with some initial values in them so that we can directly start practicing. Sometimes you may need to perform operations between these two vectors like addition, subtraction, multiplication, division, and so on. Some of these things will work the way you think they are, some of them will not. So, adding or subtracting two vectors is very easy. Let's save the result in a variable, so addition equals to first vector plus second vector. It's that easy. Let's run it. So we get 2, 4, 6, 8. Exactly what we would have expected. Same goes for subtraction. Subtraction first vector minus second vector. We should get only zeros. Only zeros, and we do. Now, nothing surprising here. We can also perform the same operations on a single vector with only one number. So, if we want to add some number to the vector, like addition with number, first vector plus 5, we will get 6, 7, 8, 9. If we do the same thing with addition, I'm just going to copy and paste it. So, with subtraction, like this, and this is subtraction. Let's run it. It works just as expected, nothing too fancy here. You can multiply with a number, so multiplication with num first vector times 5. We get what we expected. You can do the same thing with division. Basically, you take your vector, use the given arithmetic operation, the number that you want, and it works. So how can this be useful? Let's see a simple example. Let's say that we want to track our protein intake over the week. So let's say that our recommended protein intake is 150 grams per day. So recommended protein intake equals to 150. Then we have our protein intake. We have recorded it, and we know how much protein we had each day. So we had 100 the first day, 112 the second day. Alright, so we have data for 7 days of the week. If we want to find the difference between the recommended intake and our actual intake, to see if we manage to keep up with our diet, so we can say difference equals protein week 1 minus recommended protein intake. Let's run it, and we can see that the first day we had 50 less protein than we had to have. Then we have minus 30. On the third day we had a little bit of extra proteins, and so on with the rest of the days, until finally we had just the right amount of protein. Now, vectors are not usually used just in their raw form like we're seeing here, not just as numbers. They are usually visualized on a plot. So we don't yet know exactly how to do this. We haven't covered it in the course, so I'm just going to copy and paste a piece of code that will plot this so that we can visualize it. And let's run it. We can see the blue line here, so let me maximize it. The blue line is our 0, and whatever is below the line are our negative numbers, whatever is above the line are our positive numbers. Down here we have 1 to 7 each of the days. We're going to talk a lot about plotting. I just want to show you that this is the way that vectors are used most of the time. They are used to manipulate some data and then visualize it. Now, from this graph we can immediately see what was our protein intake. Now, let's cover the rest of the arithmetic operations and move on, because we have a lot more interesting things to check out, and I don't want to spend too much time on these simple things. If you're wondering why I skipped the rest of the arithmetic operations between two vectors, I did it because we need to take one extra step. To perform the rest of the arithmetic operations between two vectors, we need to use one additional operator to the arithmetic operators. If we want to multiply two vectors element by element, and this is the keyword here, element by element, the keywords, we have to use a dot in front of the arithmetic operator. So if we want to multiply the two vectors, we will say first vector dot multiplication second vector, and let's run it. We don't need this anymore. So we get 1, 4, 9, 16. 1 times 1, 2 times 2, and so on. We get what we expected. If I remove the dot, this is not going to work. We get an error because this is a different kind of multiplication that I just attempted to do, and we will see this in another lecture. Now, you can use the dot operator to perform pretty much anything. Division. Let's run. All right, so multiplication, division, and powering. The dot here makes any arithmetic operation to be element by element. It's mostly used on multiplication, division, or powering because addition and subtraction are element by element by default. One very important thing here to know is that when you perform an element by element operation, both vectors must be of the same size. Otherwise, you will get errors and your code will not run. This is true for addition and subtraction as well. Vectors must be of the same size. So if I change the size and run it, we get an error immediately on the first operation that we try to do to perform, and our code doesn't execute at all. Now let's quickly document our code. So here we have addition and subtraction to vectors. Here we have arithmetic operations between a vector and a number. And here we have an example, protein intake example. And here we have element by element operations. All right, let's move on to the next topic.